In this video, we're going to take a look at how to find area in polar coordinates. So the question is, find the area of one petal of r is equal to cosine 2 theta. And cosine of 2 theta has a period of pi, and I'm going to only graph one period, even though generally I would graph two if I was going to sketch the whole curve. But since we just need one petal, I'm only going to sketch one. So we have a range of -1 to 1, and I'm going to do increments of pi over 4. So we have pi over 4, pi over 2, 3 pi over 4, and 2 pi. And cosine starts at 1, and at pi over 4 we're going to be at 0, pi over 2 we're going to be at -1, 3 pi over 4 back to 0, and pi back to 1. So here's one period of cosine 2 theta. And now I'm going to draw it. So when theta is 0, r is 1. So we have 1 here. And when theta is pi over 4, r is 0. So we're at the origin. And then when theta is pi over 2, we're -1. So we're going to go in the negative direction, 1. And when theta is 3 pi over 4, we're going to be back at the origin. So right now our curve is going to look like this, what we have. And that's all we needed was one petal. So we want to find the area of the shaded region. And our limits of integration for this curve part that we're looking for, the one petal, is from this point here, which was pi over 4, to 3 pi over 4. So now our formula is area is equal to the integral from alpha to beta of 1/2 r squared d theta. So now A, or area, is equal to from pi over 4 to 3 pi over 4. And I'm going to put the 1/2 out front times r squared, which is cosine squared 2 theta, d theta. And then for the next step, we're going to need to remember that cosine squared theta is equal to 1/2 1 plus cosine 2 theta. So now I'm going to rewrite this with our identity. So we have 1/2 from pi over 4 to 3 pi over 4 of 1/2 1 plus cosine of 4 theta. We already have a 2 theta here, and we need to double it, so it becomes 4 theta, d theta. And now I'm going to move my 1/2 that's inside my integral out front with the other 1/2. So I have 1/4 times, and now I'm going to write this as two separate integrals because we're going to need to use u substitution for cosine of 4 theta, and we're not for 1. So I'm going to have the integral from pi over 4 to 3 pi over 4 of 1 d theta plus the integral. And now our new integral with our u substitution, if we say u is equal to 4 theta, du is equal to 4 d theta, and then 1 over 4 du is equal to d theta. So we have a 1/4, which I'm going to put out front, and then we're integrating now cosine of u du, and our new limits of integration are going to be, if we put pi over 4 times 4 gives us pi, and 3 pi over 4 times 4 gives us 3 pi. And now we're going to integrate. So we have 1/4 times the integral of 1 d theta is theta. So we have theta evaluated from pi over 4 to 3 pi over 4, plus 1/4. The integral of cosine of u is sine u, from pi to 3 pi. And now we're going to evaluate. So we have 1/4 times 3 pi over 4 minus pi over 4 plus 1/4 times sine of 3 pi is 0 minus sine of pi is 0. So we're left with 1/4 times 2 pi over 4, which simplifies down to pi over 8. And we're doing area, so we'll say units squared. And that's how we find area in polar coordinates.